走吧，你们走吧。
不要，又跳了一节，但一直3节课跳了2节。
太棒了！
第一次给忘掉了，第二次以为
睡觉了，你都。那你们刚刚不懂，我看你们这白点儿，看着不懂就不懂啊。
我把手交给你。
不用了，不用了。太多，努力一下，你能追到他，对他找你手到手。我一路过来了，没有，我跟你前面来的。你为什么没带我？我没带你，那他走。
我这一会，你要吗？
我知道了，我也知道。你是从那个就正远的那个。你就是为了凑够。不然。哪个？不要脸。你设题目的这个是什么问题？怎么题目？就是他做过这个运动，我就不用了。已经够了。你过来干嘛？那。我服了。哦，好像懂了一点点。
哎呀。
他会变好的。我相信。我看到了，你12点多回我，说你睡得那么早，12点就醒。然后一直在3点好像懂了就走了。你没跟你家人发信息吗？我睡得真的太……今天早上5点回来。什么？今天早上？发信息不可描述。你自己猜吧。对。说外面冷得一逼，他回来换个衣服。说晚了。
看不见了。
看不到吗？
还行。这是写的啥？
真的，我真的给他跪下了。真的。
那也是。哟，我去。
我的那包套他一直没舍得吃，留着周日吃呢。周日吧，国内是周6，对吧？我们过国内的。你们每次都过国内。因为这个门还是国内啊。
什么呀？周六有什么？啊。元宵节。啊？放着。
吃汤圆。
不用拿着。哎，前面胖子体积太大了，这样。
叫他帮你点点。
哎。不。 帮我放在那个空位那个上面。
上我们学校没有课程。
哎呀，大兄弟，请问
这个要上他是邮件收到是13号上。
这个吗？怎么抬啊？
可以了吗？
到底有没有回答？哇，带个灯哈，
这不是我，这不是，而且也不是灯，录像的。
他没来啊。
录像了呀。
只是改造的像
那个灯一样。
本来就是用那个台灯来录的。
今天又是啥？
阿里亚克，他听了没有讲？没讲啥。你把它写的要拍上。
The next little bit of RDF that I want to try and explain is something that's not specific to the RDF XML format. It appears in all of the RDF formats. So properly speaking, it's an aspect of the RDF data model that I've not actually really talked about so far. So what I want to try and do is try and explain to you what this is and where it comes from. So earlier on I gave an example of a little graph to describe that article about the semantic web. As a matter of interest, how many of you read that article, the original Tim Jim Nora article? The semantic web and semantic web revisited. Right. Can I suggest very strongly to those of you that haven't read either article that you read those articles? They will help you, they'll give you a lot more context for this. The way this module is organised, we've got 3 lectures a week over, 12 weeks. That's 36 hours. There's a coursework worth 25%. A lot of your time should be spent on background reading on this module, and I've given you a very good list of resources that support what I'm doing in lectures. So I strongly recommend that you read some of those. Okay. So this is a description of that original semantic web article. So you've got a thing, its title is semantic web, it's a Dublin Core title, it has a Dublin Core date, which is May 2001, it's got a creator, which is Tim Berners-Lee, a creator named Jim Hensler, and a creator named Ora Lassiter. Now, the issue here is, what order do those authors appear on the paper? They appear, well, Tim is first, Jim is second, Ora is third. The problem is that there's no way, so far that I've shown you, that we can describe the order in which certain things appear. So effectively what we've said is, this paper has a creator Tim, a creator Jim, a creator Ora. What if instead of saying this, we wanted to say, this thing has a series of creators who are in order Tim, Jim, and Ora. So just to make this quite clear, within what I've shown you so far in terms of triples, there's no way to represent ordering of property values if we want to represent an ordered sequence of things. But that's something that we will frequently want to do when we're dealing with real-world data. Now, RDF, unfortunately, is never something to make these things simple. In RDF, we don't have a way of doing this. We have 2 different ways of doing this, unfortunately. And there are pros and cons of each, and I'll try and get those across in this bit of a lecture. So, where we left off last time. RDF has 2 ways of indicating that things appear in a certain order. It has what we call a container and what we call a collection. Now, this is the container vocabulary. What we have here are a bunch of special properties that exist within RDF that are called the ordinal properties because they indicate order within a sequence. So these are all taken from within the RDF namespace, and these properties have names _1 for the first thing, _2 for the second, _3 for the third thing, and so on. And there are infinitely many of these things. So the way that the IDF vocabulary is designed, the IDF vocabulary, the basic vocabulary is actually of infinite size, which creates a few problems down the line, but I'll talk about those rather later. In practice, these things only get created as they are needed. So let's say we have let's say this represents an organisation, and we want to talk about the members of the organisation, and we want to talk about them, say for example, in the order in which they became members, or there's some ordering for them. So, this thing has a group of members, which is a thing, which has a type, and I'll talk about container types on the next slide. But within this thing, there are three things associated with it. The first of them is this, John at example.org. The second is Bill at example.org. The third is Sally at example.org. So, rather than doing things like this, where we say, here is a thing, it has a creator this, a creator that, a creator the other, so that's three triples. Here, we're having to say a few more things. So we've actually said, rather than this thing being, say, created by this group, rather than this thing being created by, say, this person, this person, this person, we say that it's created by a group of things. So we've got a triple there. We have a triple for each of the things that are going to be members of this group. And we have a triple to say what kind of collection, what kind of container this thing is. Now, again, because I should point out that this is kind of a hangover from the very early version of RDF, and it's something that still is used, admittedly more in legacy data than in stuff people are creating now, because there are interesting issues with this. They created three types of container used in RDF. So, if we're looking to list things in a particular order, the type of the thing, so the type that we give here, should be an RDF sec, an ordered group of things, a sequence. If you want to say there are a bunch of things which are a group of things, but they may be unordered, they may have duplicates in them, we want to describe this thing as a bag. Now, the thing to note here is that you may have a graph like this, which uses these ordinal properties, so, first, second, third, but if this thing is a type bag, you're effectively being told that actually, ignore the ordinal connotations of these things. There is actually no order in between these things. The third type of container is a thing called an alt, standing for alternatives. Now, do you see these things in the wild? Well, the answer is yes, you do. However, this by far is the most common thing, because most of the time when people want to talk about a group of things in order, this is the only way they can talk about it, so they'll use RDF sec. The distinction between an RDF bag and just repeating the property a number of times, providing you don't have duplicates, is minimal. So bag only tends to be used where people want to say this is a group of things and there are duplicates. It doesn't tend to get used otherwise. So this is still relatively common. This is used, but uncommon. The third example here, RDF out, I don't think I have ever seen it used in the wild. Partly because it's not very well specified. So if I have a little graph that says, let's say I have let's say I've got a resource, and I'm trying to represent the fact that there are, let's say, a bunch of different translations of this resource. So I could say, well, okay, there are translations. Translations are an RDF out, and there are a bunch of translations out there. So the first one is this thing, The second one is this thing. The third one is that thing. In the semantics of RDF, this doesn't actually have any clear meaning. It's not clear whether this means that you're effectively saying this thing is a translation, that thing is a translation, that thing is a translation. It is just, in short, not clear. So RDF out. The only times you're ever likely to see it used are for people who don't quite understand how problematic it is as a construct. So, sequence you're likely to see, bag you'll sometimes see, out in practice you'll never see. Now RDF XML has got, because it couldn't be easy, RDF XML has got a special syntax for expressing these things. So rather than having to go through and say, you know, RDF _1 _2 _3, RDF XML has a syntax that's kind of derived from the sort of list syntax that things like HTML has. So here we have a little graph, an RDF XML fragment that represents that graph we saw earlier. So here we have a description about example.org. Example.org has members, which are a thing which is of type bag. So it'll treat this as the class abbreviation syntax in RDF XML and as an anonymous resource, because there's no RDF about there. And this thing contains list items, LIs. So John, Bill, Sally. Most of the time when we write to RDF XML, it doesn't matter what order we put things in the file, it will still produce the same graph. This is the only time, almost the only time in an RDF XML document that the order in which things are written down changes the graph. Because what a parser will do when it reads this is to go, well, this is the first LI I've seen in this container, so this is _1, this is the second one I've seen in this container, so this is _2, this is the third, _3, and so on. So effectively it changes the parsing behaviour here and replaces these RDF LIs with the appropriate ordinal property. Now, containers are, as I say, the sort of legacy way of representing groups of things that possibly have order within RDF. So this goes back to the publication of the original RDF spec back in 1997, I guess. Around 2000 there was this attempt to clean up RDF. So the original semantic web specs that appeared in 97 was basically the RDF spec by itself. RDF schema had been partly written and it had gone a little way through the standards process and then it ground to a halt because people couldn't agree on it. In 2000, and I should also say, to begin with, RDF was only ever intended to be a sort of metadata language for describing web pages. It was before people had sort of cottoned on to the fact that you could use it for more general things. That all came around 99-2000 when Tim and a few other people started saying, hang on, we can build web data for this stuff. So, at that point, there was a new RDF group constituted that was going to go back and fix some of the errors in the old version of RDF. And trust me, there are some horrific pieces in the old RDF that I don't even bother telling you about because, firstly, you'll never see them, and secondly, when you think about them hard, they're really horrible and they make it very hard to reason with. So, and also they're quite dangerous in terms of what they let you say. So in 2000 they chartered, well 2001 they chartered a new working group to revise RDF at the same time that the OWL language was being written. And containers were held up as being particularly problematic. And one of the reasons they were held up as being problematic is because they're mutable. So one of the sort of underlying principles of the semantic web is anyone can say anything about anything. So if I try and show you what I mean and why I consider this to be a problem. So let's say, for example, I'm trying to do something slightly daft. I'm trying to build a a sort of a semantic web-based, how can I put it, a semantic web-based sort of authentication and access control system. So I'm going to store in an RDF file all of the people that are allowed to access a particular system. So here is my system. Here is the property. Let's call this something like allowed access. And I've got some people here. I've got John, I've got Bill, and I've got Sally. So I've effectively said these three people are allowed access to that system. And let's say I'm actually going to give this particular bag here a URI, which I can do. They don't always need to be anonymous. So let's say this is the group of, let's call it allowed users for some URI that's used to identify this. This is great. Now, I'm reading RDF from a bunch of different sources. I'm sticking it together. I'm consulting my RDF knowledge base to work out who's allowed access to this system. Unbeknownst to me, one of the other sources that I read from, somebody's added data to it, and they've said in this other source that amongst this group of allowed users is, I don't know, Dick Nasty. And he's added himself, he said that he is the fourth member of this group of things. Now, these two things are the same thing, so effectively what he said is he is also a member of that group. There is no way for us to tell easily that something has been added to that group. Adding something to that group hasn't broken it, it hasn't made it ill-formed. He could have done other things and said, so for example, actually, I'm the second person of this group. So he just tried to supplant Bill. There's no way for us to tell that actually this is a slightly broken list because it contains a first item, two second items, and a third item. That's not in the RDF spec. There's no way for us to tell that these things have been changed. So when the revision of RDF happened in the light of building out, the people who were building out said, well, hang on, there are all sorts of problems with this because there's some of the things we want to do. We want to be sure that people haven't added extra definitions to things. And the existing way that we've got to represent a sequence of things or a group of things doesn't let us know that. So, a container from the original RDF version is a mutable thing. Third parties can add new things to that. And they can add new things to it either by saying, I've got an nth element, or they could try and copy an existing element within it. The second version of RDF that came along in about 2003 from this effort started in 2001 introduces a new way of representing sequences of things. And this time it's only sequences. It's not used for, or it's not typically not used for things like unordered groups. These things are immutable. So people can try and alter them, but if they alter them, they break them. So it's easy to spot if somebody, after a collection has been created, has tried to add a thing to that collection. Now the way in which these things are represented, how many people here have programmed in Lisp or Scheme at some point in the past? Right, okay. How many people have done things like write a linked list in any programming language? Right, that covers a few more people. So effectively, a collection, in the way it's written, is a kind of linked list that represents the constant cover list that you find in the Lisp family of languages. And there are also equivalents in other languages. There are similar things that you find in Prolog, for example. So what a collection looks like is something like this. So let's say we've got this thing, we want to say we've got a group of members of this thing. Here we have an object that is a list. And the way we describe a list is to say that the list has a first item in it, and then it has the rest of the list. And the rest of the list will be one of two things. it will either be another list, or it will be null, an empty list. So, to try and walk you through what this is trying to say, so, examples.org has members which are a list where the first item of the list is John, and the rest of it is a list, the first item of which is Bill, and the rest of which is a list, the first item of which is Sally, and the rest of it is empty. So we're effectively trying to build a tree structure to represent these things. Now, the way in which this is described within RDF is such that you can, so it's described in such a way that something that's an RDF list can only have one first thing and one rest. So there's no way for you to stick something else in here. You can't add a new member somewhere in the middle here, because it will break one of those two constraints. You can't add extra things on the end, because the last item in this list already has a rest that is the empty list. So you can't add extra things there as well. So this is designed to be something, as I say, that is immutable. Or rather, it's something where you can attempt to change it, but if you change it, it's no longer well formed. So you can change it, but changing it breaks it, and breaking it will be spotted. Now, this requires rather more triples than a container does. If you think about a container only requires, well, excluding this triple here to point to the thing, a container would basically have a type for the container, access or out, and we'd have an ordinal property for each thing in the container. So 1 plus n ordinal properties for the n members of that group. For a collection, we have more than this. We have 1 type and then 2 for each member in the group. So in the general case, this will take about twice as many triples as a collection as a container will, but it has the advantage that it's immutable. Now, the downside of having something that requires this many more triples is that it is a bit of a drag to write out in full. So within RDF XML, we have a special syntax for expressing a collection. We indicate this by using an RDF parse type. So when we see RDF parse type here, what that means is the contents of this XML element, the members element, should be interpreted as the items that make up a collection. So this is the other place within RDF XML where the order in which things are written matters. We have the first case for containers, back, second out. The second case is where we have parse type equals collection. So this will be interpreted such that the value of this thing will be the object of the triple with subject example.org predicate members. The object of that will be an anonymous object, B node, whose type is RDF list, and then we'll create the first and rest items for each of these. So we'll create the parser will create that structure for you. So you have these 2 ways of trying to represent sequences of things. Practically speaking, they both have issues. Containers, it turns out, are actually really nice to query. It's very easy to work out what's in a container, but it has this problem with mutability, and its meaning in the semantics is unstated. It has no special meaning. Collections are a right pain to query when we're trying to use something like Sparkle. So if you're trying to work out if a collection contains a certain item, effectively you have to write a Sparkle query that walks down through that collection looking at each thing in turn, which isn't pleasant. That said, and the other thing here is when you're storing these things, they take up twice as much space as a container will. So what I'd say, in the general case, you're not likely to find people using either containers or collections when they're creating RDF data, unless you're looking at quite old legacy data. Where you will find this used, collection, collection ends up being reused for trying to represent some things within the OWL syntax, and I'll talk about that more next week when I get on to talking about what OWL is and how OWL works. So, RDF-XML, most of what you need to know to be able to interpret RDF-XML, you got in about the first 7 or 8 slides of this topic. It's a mark of how horrid RDF-XML is that most of the rest of it is instead trying to point out the places where you'll find the oddities and the exceptions that don't make sense. So RDF-XML is, as I've said several times already, not a nice syntax. Fortunately, we have other syntaxes. So, RDF-XML is a pain to write. You'll notice that I've not written any RDF-XML on the board. I may well have done so by the end of this module, but I'm hoping that I don't have to, because RDF-XML is a horrid language to write by hand. How many people have actually tried the worksheet? Well, I'm not expecting many of you. Some of you, well done. It's long-winded to write. It's easy to make mistakes if you're typing it by hand. It's just not nice. N3 was originally proposed by Tim Berners-Lee as effectively a simpler syntax for R. It was intended to be something that firstly was easier for people to read, it's easier for people to write by hand, and in particular, it was easier for people to write on a whiteboard. So you can sit there and draw graphs. You can sit there and draw graphs like this on a whiteboard, but there are times when it's easier just to try and write it in another syntax. And RDF-XML is not the right thing for that. So, N3, the other thing to get across is it's not just one syntax, it's a family of syntaxes. So the original N3 was something that Tim dreamt up for use with his own tool. And it's got its wacky edges, and it's not very well specified, because it was never intended to be a standard language. As people went along, they realised actually there are good reasons why we might want a simpler syntax that's actually described in the standard. So, the first sort of sub-language of N3 turned up, about 2004-ish, I think, maybe, I think about 2004-ish, maybe 2005. When the Sparkle query language was being specified, one of the steps that a standard goes through is what's called candidate recommendation, which is basically, can you build an implementation of this thing? In order to build implementations of Sparkle, they needed to write a test suite of data and queries they could use to demonstrate whether a given implementation was actually working correctly. And in order to write that test suite, they needed some easy way of writing down the test data and the queries. And rather than doing an RDF-XML, they came up with a very simple language based on unit written they called in triples. So, the general syntax for this was that you write down triples one at a time, typically one per line, and you just write down the triples as subject, predicate, object, full stop. For these components, for the subject and predicate, which will be resources, you show that something is a resource, you refer to them by URI, and you show that these things are URIs by putting them in angle brackets. If you've got something that's a literal value, you put it in quotes. That is then triples by itself. It's a very simple little language. It's a little bit long-winded because you end up having to write out every URI in full each time for each triple. But if you actually want to do things like count the number of triples, it's dead easy to use. So this is something which they could use to build up their test case data set for testing the implementations of the language. Was actually quite influential. So if we look at what this would look like, here is a simple n-triples file. About thinking about it, the subject, predicate and object don't really need to be on the same line, but they normally are put on the same line. The only important thing is the full stop, which is used to indicate the end of each triple. So, a simple little file like this, title American, has a title, title American, just literal, we would write just as this. So we've got www.simon.com, brackets to show that it's a resource, has a doubling core title, we've given the full URI for that, in angle brackets to show that it's a URI, and that property on that subject has this value, Scientific American, which we put in double quotes to show that it's a literal value. And so we would create a triple like that for each, we would create a statement like that for each triple that exists in the graph. Now, this is all very well. So all n-triples files are trivially N3 files. They all conform to the N3 spec. What some people said is actually we need a sort of a halfway house between N3 and N-triples. N-triples is dead easy to write, but it's long-winded to write. N3 has got some nice conventions for abbreviating things, which make a great deal of sense and which are easy for us to write. But it also has a bunch of other stuff that's just plain crazy. So, what we want to do is to sort of identify the sort of minimal, the maximal same subset of N3, the bits of N3 that everybody agrees on that makes sense, that fit in with the rest of the RDF data model. And so for this, we have Turtle. So Turtle is one of the other families, one of the other languages in this family. Turtle is a standard, it's gone through, it's a recommendation from W3C. The Turtle, in terms of stuff out there in the world, is fast becoming one of the more popular formats, certainly the things that people can read that they expect people to look through. It's common for things that people write by hand, but they expect people to read themselves. Now, to give you an example of the sorts of things we can do in Turtle or in N3, let's say we have a pair of triples that have the same subject. So, for example, they all have a creator, John, and it has a title, for example, in homepage. We could write each of these triples out in triples. We could repeat the subjects, or we could use this semicolon. So semicolon basically says, and now you're going to see another triple that's got the same subject as your current triple. So, rather than writing subject, predicate, object, here we've written subject, predicate, object, predicate, object. And this means that effectively the subject of this second triple here on this third line must be the same as the subject of the previous triple. And at the end of a group of things like this, you then have a full stop to indicate that you've finished with this common subject melange. Okay, that's quite a nice bit. That makes it a little bit simpler. We've not had to read examples at all. Another piece of abbreviation we can do, if we have a pair of triples that have, let's say we've got a pair of triples that have the same subject and the same predicate. So I'm going to So let's say I've got my subject, so http example.org, and I want to say that this thing has a DC creator, which is mail to john@example.org, and a DC creator, which is mail to jill@example.org. Now, if I were to write this out in n-triples, I've got to write each triple out in full, so subject, predicate, object, subject, predicate, object. What I'd like to be able to do is to say, here I've got a bunch of triples that share not just the same subject, but also the same predicate. And the way that I can do that within Turtle and N3 is to use the comma operator here. through this, I've got a subject example.org, a predicate creator, an object John at example.org, and then I've got another triple that has the same subject and the same predicate, but with object Jill at example.org. So those two abbreviation syntaxes involving the semicolon and the comma allow us to remove an awful lot of repetitive material that would otherwise be present in an N-triples file. Okay, other things that we can do. In RDF, we don't need to write all of these URIs out in full in RDF XML because we've got namespaces. We also have namespaces within N3 and Turtle. So we can, at the top of our file, introduce any namespaces that we want to use using an @prefix declaration. And this is entirely analogous to the way in which XML has XML namespaces. So, for example, here we can say there's an @prefix DC:, and that refers to this URI prefix in angle brackets. You finish each prefix line off with a full stop. So this means that instead of trying to write, example.org, HTTP example.org has an HTTP perl.org DC elements 1.1 creator, we can just write the Q name there instead. We can write DC:creator. And we can do this for all sorts of things. So we can do this not just for things that are in the predicate position, we can do it for things that are in the subject position, we can do it for things that are in the object position. So this is a general purpose way for us to abbreviate the URIs that we might find in an N3 file. This is the thing, more than anything else, that makes writing N3 and Turtle easy to handle, because we can write the abbreviation. And by the time you get around to then including things like the colon and comma operators, so the semicolon and comma operators, we can then remove an awful lot of redundancy in what we're writing. So, we have abbreviations for namespaces. Other things that you'll occasionally find, sometimes you will find people creating resources that aren't full URIs. So something like this. Here we have a resource that we're only referring to using the name #John. Now, that would normally be interpreted as something relative to whatever the URI of this document is. So if the URI of this document was example.com/ontology, the URI of this subject would be example.com/ontology #John. We can also include a base declaration here, which basically says if there are any URI fragment identifiers that exist in our document, resolve all of them, not relevant to the URI of this document, but relative to the base URI that you've been given. So again, this is exactly analogous to the way in which the base element works in HTML. So in HTML, base element lets you write pages with fragment identifiers in and partial URIs that resolve relative to that base element's value. We've got exactly the same thing in here. So if we were to interpret this and say what triples this contains one triple whose subject is example.org/data #John, whose predicate is xmlns.com/post/0.1/name, and whose object is the literal John Smith. Other bits and pieces. Enter in Turtle, we have B-nodes, just as we had B-nodes in RDF XML. In Enter in Turtle, there are effectively two ways in which we can create a B-node, create a resource that hasn't got an identifier. So the top way of doing this is to use these square brackets, so the square bracket here and here. So that top line, the way we would read this is to say, there is a thing, example.org, which has a DC creator, which is an anonymous thing whose name is John Smith. So this will effectively create for us, write this down, this will create for us the following graph. So we have example log of a DC creator, which is a thing that's anonymous, that has an EX name John Smith. We still, with this top notation, have the same problem that we have with RDF, in that if there are cases where, for example, we have two different references to anonymous objects, but we want to make sure that they're the same anonymous object. Just as in RDF XML, you have node IDs, within M3 and Turtle. So, all of our anonymous resources, the node IDs, we create in a special namespace called underscore. So underscore colon basically means this thing is an anonymous resource, and foo23 will be the identifier that we use for this anonymous resource in this particular serialization of the graph. So this is not something we can refer to externally. So what are we saying here? This is exactly the same example that is in the RDF XML example. We have two websites, www.example.org, test.example.org. They each have a DC creator, which is this anonymous object for which we're giving a local ID foo23, node ID foo23, and that thing foo23 has a name which is John Smith. That is effectively Turtle in a nutshell. As you can probably tell from this, I spent a lot longer talking about RDF XML than about Turtle. Turtle that much simpler. However, of the two languages, one of them is taken to be the normative format, the sort of official format for RDF, and unfortunately, that's RDF XML. So even though you might see people writing stuff in Turtle, the only format that you should be able to rely on all tools supporting is the XML format. It kind of sucks, really. So yeah, talking about the history, so original version, sorry I said 97, that's when the working group started. Original version published in 99, a new working group formed in 2001, they published their version. I've remembered it's 2003, it's actually the very beginning of 2004. There has been another RDF working group working on this since, but to some extent they've not spent as much time looking at the core of the language as the previous working group did. There are a few little revisions that I don't think they're really significant. I mean, the main thing is that they've identified the Turtle syntax as, I mean, the status of it has changed a little bit. They've also introduced a JSON syntax, JSON LB, which I'll try and find space in another lecture to talk about. And they've also introduced the notions of things like module graphs and graph stores, which mostly come into the way that Sparkle is defined. But now they're on a sort of slightly more firm theoretical foundation, because they can talk about a particular graph having a URI, which means we can then make statements about graphs more effectively. Places to read up on this. The main specs are all held on the RDF homepage at W3C. If you want to go through and look at what working groups do and you want to see what happens inside the sausage factory, then have a look at the working group homepages, but beware there are thousands and thousands and thousands of emails of people having disagreements on what RDF should look like. There's a primer that was written by that's not, I need to check that. Try to remember who wrote the RDF primer, because it wasn't Tim Berners-Lee, it was somebody basically trying to fathom the mind of Tim Berners-Lee. Oh no, it is Tim Berners-Lee, he did do it in the end. Sorry, I should say Tim Berners-Lee. Tim Berners-Lee with his director hat off, which is Tim trying to make it clear that it is his ideas of what a syntax could look like, but it shouldn't be construed to mean a standard. I spoke about RDF XML in terms of data type, and that's something that I've skipped out of the surface stuff and trying to fit it into the lecture. All of the data types come from the XML schema data type part 2. So as part of the XML schema documentation, there is this thing which gives all of the data types that you can use within RDF. And I'll list them somewhere. Built-in data types. So we've got things like duration, date, times, booleans, strings, floats, decimals, doubles, and so on. So these are all things that you can annotate a literal with. Okay. Thank you very much. Any questions?
Just a
Okay.
document.
Have a good weekend, and I should be
一样还是一个大概，到时候最后一个片段，什么？我跟你讲，你听不懂，听你前面没有。
是还有一节课是吧？
没有了吧？
没有了吗？啊，没有了。
我操！没有了。等我看他们走不走。
哎，为什么我显示有的呀？
我他妈是一节。我显示有的。我是一节啊。
我操！
我也显示。我跟你一样的，我跟你不一样。
哇，这么难受的吗？问一下。大哥，还有没有课？
下午吧。
啊，那个课不上了。
是一节吧？对呀。